Hey guys, so for this video, you are not going to see my face for a little bit. Sorry about that. You have a, if you go to my website and print this document out, you can kind of just follow along with me. So you're just going to see my hand and you're going to see this printout. And then when we do a couple of examples, I'll film them like I did before. Okay. So this is one example of how an ellipse can look. This ellipse is longer in this direction and shorter in this direction. And if you notice, I want you guys to notice all the labels. So see how it says vertex and vertex? The vertices are always on the long side. The co-vertices are on the short side. The center is right in the middle. And like I mentioned in my other video, there are two foci, symmetrical about the center and always on the same parallel line as the vertex, okay? The major axis is the long one and the minor axis is the short one. Because those are kind of like the basic vocabulary you need to know. Okay, so today we're going to talk about the equation of an ellipse, and for that you need to know what some of these numbers mean. Okay, so we have our first letter is going to be A, and that is the distance from the center all the way to the vertex. Okay, so A is the distance from the center to each vertex. Okay, so of course A is also over here, center all the way to that vertex. Okay, all right, another letter is B, and that is the distance from the center to the co-vertex. So B equals distance from center to co-vertex. Okay, and then of course there's one more letter, and that would be C, which I always remember because the word focus has a C in it. C is the distance from the center to the focus. So C is the distance from the center to the focus. Okay, ooh, I spelled that weird, sorry, that's an S. Okay. All right, so one of the things that's really important, and I had a way of showing this to you guys a little bit better, but I'm actually at home now, so I don't have like a projector or anything, is there's a relationship between A, B, and C, and it all comes from that. Remember that video I showed you guys about how you can draw it with a string? If you put your like toothpicks here, and your string was exactly laid out here, then this distance would be the distance of your string. It would be 2A, okay? So then if you had your pen right here and you drew a line right here, okay, each of those would equal A because the distance A plus A has to equal the length of this, which is 2A. I know it's like hard for me to explain that properly without being with you guys and actually having the string, but the thing I really need you guys to get out of that is this right here forms a right triangle. So for every single point on an ellipse, there's a relationship that B squared plus C squared equals A squared. So A squared equals B squared plus C squared. So be careful because it looks a lot like the Pythagorean theorem, but the letters are kind of switched. So the way that I remember it is because A is from the center all the way out to here, it is by default bigger than B, because if B was bigger, then it would be taller. And because the focus is before the vertex, A is also bigger than C. So the way I just remember this is I don't worry too much about the A's and the B's and the C's. I just make sure that this is always the biggest number, okay? Because you know in Pythagorean theorem that the biggest number obviously has to be by itself. So I just realized that you guys might not be able to see that. Let me write that again. A squared equals B squared plus C squared. There, you can see that better. And A is always the biggest number. Sorry about that. There's going to be some technical difficulties. Okay, so that's what you need to know about that picture. Now I'm going to add a picture. Sorry, my cat's sitting on it. This is, you also had this. Basically, I just took the other picture I had and turned it sideways. This is also how an ellipse can look, okay? This is when it is taller than it is wide. And if you guys notice, pretty much all the words are the same. It's just where they're located is different. So in this case, A is still the distance between the center and the vertex. B is still the distance between the center and the co-vertices. And C is still the distance between the center and the focus. All of that stays the same. It's just because in this problem, A is bigger, then this is a larger distance than this, therefore making the shape longer. And I'll show you in a second how that shows up kind of in the equations and whatnot. Okay. All right. So hopefully that makes sense. What I'm going to do now is talk to you guys about the equation of ellipse and all that stuff. And I don't need these papers anymore. So I'm going to stop this video, and I don't know how to pause the video and then pick it up again. I don't even know if that's a thing. So I'm going to have to stop the video and make you a new one that you should watch right now. Okay.